Okay, we got number 12, and here they are asking for us to write each portion of a whole as a percent, as a fraction, as a decimal. So I have percent, fraction, decimal. I'm going to write them right below here. We start with 0.43. We already know that's a decimal, so we got that one down. We know that if we want to write a decimal as a fraction, we just say our decimal using place value. So the first place value is the tenths. The second is the hundredths, so that's 43 hundredths. So I'm going to write my fraction as 43 over 100. Don't know of a number that goes into both of those. And then finally, to make this one out of a percent, we can go from either one. So 43 over 100, we know percents are out of 100, so it's 43%. Or we could think of it as our decimal times 100. So we move the decimal over twice, and there's 43. So it's going to be 43%. Moving down to B, I'm just going to keep going in a line here. B gives us 9/10, and they write it in words. So 9/10 in words, they're kind of giving away the fraction here. So it's going to be 9 over 10. 9/10, 9 out of 10. Same goes for the decimal, right? If we have the place value, the first place is our 10th place. So we know we can just put our decimal, and our first place is 9. That's 9/10. You also could have divided 9 by 10, right? Remember, a fraction is a division problem. 9 divided by 10. And finally, the percent. So I could take my 0.9. I'm going to multiply by 100. So my decimal is going to go over once and then twice. And there's going to be a 0 right here. So that would be 90%. Moving down to letter C. Oh, sorry, hit my camera there. 39%. This one they've already given us as a percent, so I'm going to just rewrite it right here. 39%. We've been changing decimals to percents by multiplying by 100. So to go backwards, we're just going to take our percent and we're going to divide by 100. So my decimal's right here. I'm just going to show this with a red pen here. My decimal will be right here, and it would move back once and then twice. So my decimal is actually going to be 0.39. Percent is still 39%. I'm going to just scribble that out now so we know it's gone. And then to change it to a fraction, again, I like to use my decimal, so I go place value. So my first one is the tenths, my second one is the hundredths, 39 hundredths. And I don't think there's anything that'll go into both of those numbers to reduce it. All right, final one for number 12, letter D, 16 over 25. This is already in fraction form. So I'm going to go ahead and write 16 over 25 in fraction form. I could, to make this one a decimal, I could divide 16 by 25, and that would work fine. In this case, though, since 25 can so easily become 100 by multiplying by 4, I'm going to actually change this fraction to something out of 100, and that's going to make my decimal and my percent much easier. So in this case, like I said, I can multiply by 4, and then I multiply the top by 4. Remember, this is a giant 1 right here, because 4 over 4 is just 1. And when I do that, I'm going to get 100 in my denominator. In my numerator, I get 4 times 10 is 40. 4 times 6 is 24. 40 plus 24 is 64. So 64 out of 100. And we know that percents are out of 100, so I could write that as 64%. And for the decimal, I know 64 hundredths is 0.64. All right, question 13. We have, does the decimal form of 2 over 7 repeat or terminate? We're supposed to explain how we know. I'm just going to explain to you in words while we talk through it. We know that a fraction is a division problem, 2 divided by 7. So to convert to a decimal, we're going to convert this by doing 2 divided by 7. So here's my long division problem. I put my 2 on the inside. We're dividing it by 7. First of all, I know that 7 can't go into 2, so I'm going to need to put a decimal. And I knew right away that 2 sevenths was less than 1. And now I can bring this 0 here. That's going to become 20. So 7 goes into 20 2 times. 2 times 7 gives me 14. Find the difference. 20 minus 14 gives me 6. And I'm going to the next place up here so I can bring down the next 0 that's over here. How many times does 7 go into 60? It goes 8 times. 8 times 7 is 56. Again, find the difference. Now it's 4. Again, another place value. I can keep bringing down zeros. I'm going to need to extend my division bar here. This one's going to be a little bit of a long one. I bring down another 0. 7 goes into 40. That's going to be 5 times, because 7 times 5 gives me 35. My difference now is 5. Notice that every time I've taken a difference, it's been a different number than any of the times before. Bring down another 0. 7 goes into 50. Well, we know 7 times 7 is 49. It's going to be 7 times. Now I have a difference of 1. Bring down another 0. How many times does 7 go into 10? 1 time. 7 times 1 is 7. A difference of 3. We're still going here. Bring down another 0. 7 goes into 30. How many times does 7 go into 30? It's going to be 4 times, because 4 times 7 is 28. The difference is 2. Bring down another. How many times does 7 go into 20? 7 goes into 20. 2 times. And now what's going to happen here? We started out with a 2. We knew that 7 went into 20 2 times. We had a difference of 6. So when I multiply 2 by 7, I'm going to get 14. I'm going to have a difference of 6. And we're going to repeat this whole pattern again. So I know at this point, because I've come back to the same decimal, that my number is going to be a repeating decimal, and it's going to be 0.285714 repeater. Okay, we're on 14 now. I decided to just use my actual printed out paper instead of redrawing this. So it asked me to find the perimeter and the area of each of the figures below. For letter A, we know that perimeter is the distance around the outside of the object. So I'm going to go ahead, and I think with this kind of thing, if you have the paper in front of you, it's a lot easier just to check off which ones you count. So each one of these sides is going to be 1 unit. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So my perimeter is going to be 18 units. And for the area, I'm just going to count the number of squares, because area is just the number of square units that fit inside your object. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. My area is 9, and those units are square units. Moving over to B, we have a parallelogram here. The perimeter, again, is the outside. We know in a parallelogram the opposite sides are equal. So 7 feet, 7 feet, 5 feet, and 5 feet. To find the perimeter, I'm going to add up the outside. So I have a 7, I have a second 7, and then I have 2 5s. And when I add that all up, I'm going to have 7 plus 7 is 14, plus 10 is 24 feet. And the area of a parallelogram is just going to be this base down here times the height on the inside. So my area would be 7 times 4, which gives me 28, and they're square feet. So there's my perimeter, there's my area. All right, last one for 14. We got a rectangle. Perimeter again, outside, opposite sides are the same. So this is 8, this is 15. Add them all up. We have 8 plus 8 plus 15 plus 15. I know that 15 and 15 make 30. I know that 8 and 8 make 16. So added together, that makes 46 centimeters. And for the area, it's just length times width. So in this case, it's going to be 8 times 15. 8 times 10 is 80. 8 times 5 is 40. Add those together, and I get 120 square centimeters. All right, question number 15. We have Mr. Feinberg, and he's going to read 14 pages of his graphic novel, and that's going to take him 26 minutes. And what we're asked is, how long is it going to take him to now read 30 pages? And we're assuming in this case that he's reading at the same rate. This one's going to give us a little bit of a tricky number, but it's pretty interesting. So, if I know that he can read 14 pages in 26 minutes, and I want to know what 30 pages is, I am looking for how long it's going to take him to read one page. Because once I know how long it takes them to read one page, I can take that number, whatever it is, multiply it by the 30 pages I have to read, and that's going to give me my solution. So, if I know that it takes 26 minutes to read 14 pages, I can divide 26 by 14, and that's going to give me the number of minutes it takes to read one page. So if you think about this, what I'm doing is I'm really reducing by the giant 1, 14 over 14. And my denominator becomes 1, and it's still page, or pages. And when I divide 26 by 14, which I'm going to use my calculator for, 26 divided by 14, it's going to give me this pretty wild number here. So 1.85714, and then that next part's going to repeat again. So that's going to give me 1.857142 repeater. And that's the number of minutes that it takes him to read one page. So now, like we said before, we're just going to take that number that we got, we're going to multiply it by 30. So I'm going to take 1.857142 repeater, multiply it by the 30 pages that he needs to read. And again, I'm just going to use my calculator because I already got it pulled up. And that should be about 55 point, and then all that good fun. I'm actually going to round this solution. So we're going to say it's about, I'm going to use a squiggly equal sign for about equal to 55.71 minutes. All right, last one here for this practice test. Number 16. I have 33 blue tiles. I have 17 green. I have 88 yellow. And I have 3 red. These are all in a bag. I'm going to shake the bag up, and I'm going to pull a tile out at random from here. My first question is, what is the probability that it will not be yellow? So we're looking for the probability not yellow. And the first thing I need to know is, what is the total number of tiles in here? So I have 33 plus 17 plus 88 plus 3, and my total should be 141. So 141 total. And I want to know the probability of not yellow, so I'm going to add up all the ones that are not yellow, and I'm going to divide them by the total. So I have 33 blues plus 17 green, that gives me 50, plus those 3 reds gives me 55. Oh, sorry, excuse me, 53. And I'm going to divide that by the 141 in total, and that's the probability of not yellow. Just so that we actually know what it is as a percent as well, we're going to say that's about, and again I'm rounding here, we're going to say this is about 37.59%. Excuse the bell there. Okay, what is the probability that the tile is green or red? So we have 2 here. We have green and red. We're going to actually just add those together because we'll take either of those as an outcome that we want. So added together, 17 plus 3 equals 20. And that's out of 141. Again, same total. And when I divide 20 by 141, we get about, because again I'm going to round, 14.18%.